This is a spec for the module on arithmetic word problems. Arithmetic word problems. And we're going to give students 3 different types of word problems, all essentially testing the same concepts. This is one, and the variables we're going to change are the proper nouns and then the gender with it. I actually have some helper functions in that already work on this. You can add more names if you want. But when Sal places 6 chairs in a row, that's going to be a random number, he ends up with 4 rows. So we're going to know ahead of time that we have 24 chairs. These are 2 of the factors. You can start with a 6 and a 4, know that you get to 24. And then if he wants, and of course he is going to be based on this proper noun, if he wants 3 rows, another random number, want to make sure that this is a factor of 6 times 4, how many chairs should he put in each row? Now this problem, we can make it either a multiple choice or a free answer. I'll leave it up to your discretion which one you want to do. If it's multiple choice, obviously the correct answer should be one of the choices. The other ones could be just numbers, random numbers around it. That's probably the easiest way to do it. And if someone doesn't know how to do this problem, I don't think they'll be able to intuitively guess. But free answer might be the best way to do it. Up to you. This free answer is definitely an option for this video. Now, the hints for this particular question, first time you click hint, says 6 chairs times 4 rows is equal to 24 total chairs. Total chairs. If we, this is the second hint, if we divide the 24 chairs into 3 rows, then we get 24 divided by 3 is equal to 8 chairs per row. And that's it. And the correct answer is obviously 8. And the more we can change here, and we can even, if we want to get fancy, if we want to make it look like there's even more variety here, we could even change the proper nouns. It doesn't have to be chairs. It could be apples. It could be bananas. It could be cars, whatever else. But chairs will work if we don't want to get too fancy. So that's kind of the first type of word problem we want to deliver in this module. And feel free to kind of play around with it. We could put the sentences in different orders. Even this one, the second question, if we wanted to get fancy, says if he wants to place, if he places 8 chairs in each row, how many rows does he have? So we're asking something slightly different. So you can play around with that, but this is the first fundamental type of question. The second one, the second question we have is this one right here. Sal bought 5 pencils, and as you can imagine, the random variables here are the names, the proper noun Sal, the proper noun Sal, 5. I think you get the idea. Even the word pencils can be changed, and so could with the word pen. I think you have that general principle. Sal bought 5 pencils from the store. He bought a pen for 50 cents. He spent a total of $5. All of these are random numbers, obviously, but we have to make sure that the numbers work out. So we have nice, a clean math to do. How much did each pencil cost? And you say, so the first hint will be he spent, of the $5, he spent 50 cents on a pen, so he must have spent 5 minus 50 cents is equal to $4.50 on pencils. The second hint was he spent $4.50 on 5 pencils. So he must have spent $4.50 divided by 5 is equal to 90 cents on each pencil. And once again, that should be one of the choices. We could do 80, 90, all of these, but that's going to be a random number. It's going to be generated by the program. But once again, this could be a free answer problem. Now, the last one we want to do is do this in a different color. And once again, I keep using my own name, but you want to use the proper name generator so that it gives you random names every time. Sal is making bags of candy. Once again, candy can be changed depending on if we want to make it look like there's even more types of problems there. If he put 3 pieces in each bag, he will make 31 bags and have 2 left over. He will make 31 bags and have 2 left over. If he instead puts 5 treats in each bag, how many bags of treats can he make? So this is a little interesting. There's a little bit of a remainder issue here. So the first hint we will give is 31 bags with 3 pieces each results in 31 times 3 is equal to 93 pieces, or pieces of candy. That's the first hint. 93 pieces plus the 2 left over. We might want to write that as a number 2. Plus 2 left over equals 95 total pieces. And then the final hint is 95 pieces divided into groups of 5, or bags of 5, we could write here, bags of 5, results in 95 divided by 5, which is equal to 19 total bags. And once again, our choices here could be 19, 17, 10, 8, 20, just a bunch of different numbers, and it's all going to be rearranged, obviously. Or we could make this into a free answer question. Once again, this was the arithmetic word problem spec.